Hello students, my name is Kanika and I teach mathematics to grade 9 and 10. Please be connected with me for the next few minutes. Today we are going to learn arithmetic progression from grade 10. Now please observe the list of numbers 2, 5, 8, 11, 14 and can you please give me the next number in the sequence? We started with 2, then we have 5, then we have 8, 11, 14. So the next number would be, yes, very good. The next number would be 70. So I think you've already observed the pattern in this sequence. Yes, every time we are adding 3 to the previous term. From 2 to 5, we add 3. Now, when we start from 5 and we need to reach 8, we need to add 3 again. Here also we are adding 3. Here also we are adding 3 and so on. So throughout we are adding 3. Very well observed. Very good. Now I am writing another sequence on the board. Please observe this. So we have 10, then we have 8, then we have 6, 4, 2, 0, minus 2. Now you give me the next term after this. Please observe this. So we started from 10, then we have 8, 6, 4, 2, 0, minus 2. What would be the next one? Perfect. Very good. It would be minus 4. Great. So here also you will observe the pattern. From 10 to 8, if you want to go, you're going to subtract 2. From 8 to 6, if you want to go, you're going to subtract 2. So at every step here, we are subtracting 2. Yes. Now let us observe the next one. Now I'm writing another sequence here. 5, 5, 5, 5, 5, 5. And what would be the next one? That's quite easy. Yes, the next one would be 5. So here it's 5, 5, 5, 5 throughout. So neither we are subtracting anything nor we are adding. So we can either say that we are adding 0 every time, or we can also say that we are subtracting 0 every time. Now please observe all these sequences. In all these sequences, there is one common thing, that either we are adding a fixed number every time, or we are subtracting a fixed number every time, or we are just adding 0 every time. So such sequence, they're called arithmetic progression. Now, arithmetic progression means it's a series of numbers where we can start with any number. Like in the first one, we are starting with randomly any number. So we are starting with 2 here. And every other term will be obtained by adding a fixed number to the preceding term. That means the next term, that's 5 in this case, will be obtained by adding a fixed number to the previous one. So if I add 3 to 2, I'm going to get 5. If I add 3 to 5, I'm going to get the next one, that's 8. If I'm going to add 3 to 8, I'm going to get the next one, that's 11, and so on. In the same way, we started with 10 here, and every time we are actually subtracting 2. Can I say that I'm adding minus 2 every time? Can we say that? If we subtract 2 from 10, it's same as that I'm adding minus 2 to 10? Yes, it's the same thing. So here also, in this case, we are adding minus 2 every time to get the next term. So 10 minus 2 will give us 8. 8 minus 2 will give us 6, and so on. That's how we get the other terms of the sequence. Now coming to the last sequence here, where we started with 5, and then there is 5 throughout. So we can also say that we are adding 0 every time and we are getting the next term. Such sequences, as I just told you, they're called arithmetic progression, where we start with any number and we keep on adding a certain number to get the next one. And that number has to be fixed. You cannot vary that. So if it's 3 here, it should be 3 throughout. If it's minus 2 here, it should be minus 2 throughout. If it's 0 here, it should be 0 throughout. So these are all arithmetic progressions. Now, in arithmetic progression, the first term is usually denoted by small a. This is the first term. And the common difference, that means the fixed number which we are adding every time, that's denoted by small d. That's the common difference. Now, please notice, children, here the arithmetic progression can be either a finite series or an infinite series. It can either have finite terms or infinite terms. For example, if I take natural numbers, I can start from 1 and then again the next one would be 2, 3, 4, 5, 6 and so on. The natural numbers can go on forever. So that's an infinite arithmetic progression where the first term is 1 and the common difference is also 1. We can just keep on adding 1 every time to get the next natural number. So that's an infinite arithmetic progression. Now here, as we have just observed, the common difference can either be a positive number, like in the first example I showed you, the common difference is positive 3. It can also be a negative number, like in the second example I've shown you that the common difference is -2, or it can be 0. In the third example, we could observe that the common difference here is 0. All right, children, understood till here? Perfect, very good. Now let us write the arithmetic progression in a generalized form. So we know that the first term is denoted by A and the common difference is denoted by D. We also know that in arithmetic progression, every term we obtain by adding a fixed term. Fixed term is the common difference to the preceding term. So if I want to obtain 5 here, I need to add the common difference, that's positive 3 in this case, to 2. So now I'm going to use this concept to write arithmetic progression in a generalized form. So the first term is A. The second term would be A plus D. So I'm adding the common difference D to the first one to get the second term. Now the third term, I'm going to add D to this. So I'll get A plus D plus D. To get the fourth term, I'm going to add D here. So I'll get A plus D plus D plus D. To get the fifth term, I'm going to add D to this. So I'll get A plus D plus D plus D plus D, and so on. So now we are going to simplify this and write this A I'm writing as it is. This also I'm writing as it is. Now A plus D can also be written as A plus 2D. A plus D plus D plus D can be written as A plus 3D. The next one, this one, can be written as A plus 4D, and so on. Now this is the first term. This is the second term. This is the third term. This is the fourth term. This is the fifth term. Now the first term we are going to denote by A only. The second term we will denote by A2. Third term we will denote by A3. Fourth term we will denote by A4. Fifth term we will denote by A5. So just by observing this, can you tell me what would be the 10th term of the sequence? Very good. That would be A plus 9D. Yes, the 10th term of the series would be A plus 9D. Okay, now tell me what would be the 25th term? Very well observed. 25th term would be A plus 24D. Now, in general, if I want to write the nth term of the AP, that means AN I need to write down. So it would be A plus N minus 1 into D. So whatever is here, we are taking 1 less here. I'm repeating, whatever is here, we are taking 1 less here. So in general, the nth term of the AP is given by AN, that is A plus N minus 1 into D. Thank you, children. I hope the concept is clear to you. I invite you all to join my online classes to enjoy mathematics. Thank you.